See that? Now, let me show you how not to do it. Okay? How not to do it and get a good grade is, let's do this. Control N, layout, long L, and I put down a NMOS, and I do a Control I, and I've got a width of 4 and a length of 40, and I hit OK, and I see that, and I go, okay, well, what's so bad about that? Well, first off, let's do this, Control G. Does everybody see how the connections of the source and drain are here? The current flows perpendicular to the length from one side to the other. And so this, it's not a really long device, but you get the idea. If I keep going longer, what's going to happen? Resistance is going to go up. Okay, so now I want to lay this out in a more practical way. So I can do this in one of two ways. One way is a little bit longer than the other, but either way will work. Let's do it with electric just because we're down here, and I'll show you. So I'm going to put another MOSFET down. Let's put this one over here. And let's just do a Control I and make its width 4 and its length 10. Okay. Now my current in this device flows from here to here through a 4x10 device. I'm going to take this device and I'm going to copy it, and I'm going to move it over. Whoops, I'll paste it. We'll just be sloppy here. Now I'm going to connect up and slide these together and hit fit. And now I ask, what's the overall width and length of this device? The answer is, well, let's see. The current flows through 10 here, that's the L, then over and around, and 10 here. So this is effectively, and the width hasn't changed of where the current's flowing, so this is effectively a 4x20 device. Now, do I want to connect my poly together? Yeah, I do, actually. Yeah, I want to connect these together because, yeah, they're the gate. So I move them together. Let's hit F5, no errors. And I can slide this down if I want. I'm going to slide it up. I got to pick the right one. Anyway, slide it around, or I guess I can delete and start over. Anyway, we'll put one more down, and then I'm going to go here. And now if I ask, what is the effective length from here over to here? 30. Then you can say, well, can't you take this even, so does everybody understand the basic way of laying out a long L MOSFET without taking up a lot of area? Okay, there's one other way of doing this that I mentioned. All right, no questions on this? Okay, now when you do, it should be smart enough in the LVS to recognize this, and there's a tolerance on the error when you do the LVS. It's like 5% or something. The reason there's an LVS tolerance is because of this exact example. Here, when I put these together, I'm going to have a slightly different W over L ratio because of some errors we'll talk about later. And when I draw the schematic, I won't. I'll just have one MOSFET. So what I may want to do in the schematic is just draw the long L device as a parallel combination or a series combination of devices. All right? We'll talk about that in more detail. The only thing you need to get out of this at this point is that these are in series. And the way to lay this out. One last thing, and we're out of time, and we need to do that too, is this is one way of laying out a long L device. If you look at figure in chapter 5, figure 517, if you look at the figure 517, I've just put poly over the entire length of the active instead of having the active snake around. And that gives you even a smaller layout area because all those adjoining active areas, you don't have to, you don't have a larger layout. Yeah, those extra active areas would then count in your length. Well, you want large R because it's a long, so they actually reduce the layout size and then increase the R. So, all right, any last minute questions? Let's see. Okay, sounds good. Let's go ahead and hit F10.